Welcome to part 1 of our tutorial on rendering light fields from reconstructed 3D meshes using the free and open source COLIBRI VR package for the Unity game engine. In this first part, I'll be showing you how to perform sparse and dense 3D reconstruction on a sample image dataset using the open source COLMAP toolkit, called from within Unity using the interface provided by the COLIBRI VR package. As a sample image set, we'll be using the terrains dataset from the ETH3D benchmark. If you prefer, you can use any set of input images that you have on hand, and this should work in the same way. To download this image dataset, we can simply go to the COLIBRI VR documentation website, click on the Datasets page, and type in the name of the dataset, so here, terrains. We can then click on this link and look for the corresponding download. So here, let's click on the Terrains DSLR JPEG zip archive and wait for this to download. Once the file is downloaded, let's navigate to our Unity project, create a folder called Data next to the Assets folder, and copy the downloaded zip archive. We'll then extract the files here, and once this is done, we'll make a few modifications to the extracted files. So in the extracted folder Terrains, let's first delete the folder called Calibration. We can then go to Images, DSLR Images, and here we have our 42 input images. Now performing 3D reconstruction on the entire dataset can take some time. For instance, on my setup, processing the full dataset takes about 45 minutes. There are two ways to bypass this. You can either reduce the size of the images in terms of pixel resolution, or reduce the number of images. Here, we're going to take the second option, so we're going to work with a subset of only 12 of the original 42 images. So we're going to select the 12 images here, in which we can see the captured specular highlights, and we're going to move them to the Images folder. And then, let's delete the folder containing the rest of the images. So we end up with a Terrains folder that contains an Images folder that contains our 12 input images. Now we can go into Unity. Make sure you've downloaded the COLIBRI VR package and that you've specified the paths at least for COLMAP and Blender. If you need guidance on this step, you can watch our tutorials for getting started with the toolkit. And then what we'll do is create an empty game object and add a processing component, in which we'll specify our Terrains folder. We can then launch play mode, which is necessary to launch the processing coroutines. So the first step of processing here will be sparse reconstruction, that is, recovering the relative positions, orientations, and camera parameters of the capture setup based on the input images. Now all you have to do on this step is go into COLMAP and recover sparse camera setup from images. We can leave the defaults here and click Run, and then Yes on the pop-up. Now what this will do is simply make underlying command line calls to COLMAP to perform sparse reconstruction. This step is relatively quick. It should take just a few minutes. Okay, so sparse reconstruction is now finished. This took about 1 minute and 30 seconds on my setup. If we look in the scene view, we can see that we now have an estimated camera setup appearing in the form of camera gizmos. So if this setup looks correct, we can now launch dense reconstruction to obtain a 3D mesh in the PLY format by clicking on Reconstruct 3D Mesh from the sparse camera setup. This operation typically takes much longer than sparse reconstruction, so you can let it run in the background. While this is running, one thing to notice about our main folder is that it has automatically been changed to terrains/dense/0 after the first reconstruction step. This is because the rest of our processing and rendering pipeline requires input images that are undistorted. So here, the original image dataset is automatically undistorted after the sparse reconstruction step, and the undistorted images and corresponding camera setup are exported to this new subfolder, terrains/dense/0. So this subfolder that contains the undistorted images becomes our new main folder for the rest of the pipeline. Okay, so dense reconstruction is now finished. This took about 11 minutes on my setup. We see that we now have a meshedelaunay.ply file here in our main folder. All we need to do now is convert the ply file format to an OBJ format that Unity can handle natively. This is where we'll be using the open source Blender project. So let's click on Blender, then Convert ply mesh to OBJ file, and just wait for this to finish. Okay, we've now got a meshedelaunay.obj file that we can use in Unity. And if we go in the scene view, we see that the converted mesh appears as a preview, and in the console, we've been notified that it has about 83,000 faces. Now if we select the shaded wireframe shading mode, we see that the triangles of this mesh are often quite jagged, so this isn't going to be ideal for rendering. So I'm now going to remesh the surface and simplify it. This is an optional step that requires having downloaded the open source Instant Meshes project, so if you don't want to do so, you can just skip ahead to the next part of the tutorial. Otherwise, let's click on Instant Meshes, then Perform Automatic Retopology, and here I'm not going to look to reduce the vertex count yet, so I'll unselect this. And once this is done, we see that we obtain a surface with about the same number of triangles as before, but that is paved with triangles in a very smooth, very uniform manner, which is the strength of instant meshes. So now we can simplify this beautifully remeshed surface simply to reduce the number of triangles. So let's go into Blender and run Simplify OBJ Mesh. And once this is done, we obtain this new mesh that has a nice layout of triangles and only about 43,000 faces. Let's now go to part 2 of this tutorial, where I explain how to render the obtained data as a light field in Unity.